My name is Boskey Savla. I'm a technical marketing manager at VMware for cloud native applications. And today we are going to talk about microservices and how we are bringing Istio-based management to VMware Cloud PKS. Why do we need microservice management? What are the challenges? And then maybe go through a demo of what that really looks like. So how many of you had heard of Cloud PKS? All right. Okay, thank you. And how many of you are using Kubernetes actively in production? Cool. Are you guys using any kind of a service mesh proxy technology today? Not yet. Okay, cool. All right, so let's just start. So what we're going to go through is, we can keep this interactive. If you have questions, please ask me. So we're going to look at what containers and bringing to the table in terms of architecture and how Kubernetes is kind of driving a little bit of the microservices architecture when it comes to deploying applications within containers. And what really is a service mesh? Why is it needed? What capabilities require us to bring a service mesh to microservices? What is Istio and how it fits into this whole service mesh category? Then we get into a little bit of how we are doing that on VMware Cloud PKS. We have a validated solution of Istio that runs on VMware Cloud PKS. Right now, it's going to be a self-managed deployment, but we're also working on making it a more managed solution. And then I'll probably walk you through a demo of an application that I've already deployed. It's a microservices-based application, and we're going to take maybe a look at a couple of use cases that Istio helps us solve with that application. All right. So I think, all right. So Kubernetes really kind of is an orchestration platform for containers, right? Containers really are effective at portability. They are great to, move applications, go through pipelines much more faster, but you do need an orchestration platform to manage containers. If you're running multiple containers, you need an orchestration system. That's where Kubernetes comes in. Now, Kubernetes has, apart from managing or orchestrating containers for your applications, it brings with itself its own set of framework. For example, every container in Kubernetes is based in a pod, and a pod is by default not exposed to external traffic apart from the cluster. And so Kubernetes has this notion of services where an API service is actually front-ending a specific container. And what that really means is, when you're deploying an application within a container, that container needs to be front-ended by your API service. It could be a cluster-based service, it could be a load balancer, whatever it is. But that effectively what we are trying to do is, we are going to break down your application into multiple micro segments of, just break that down into multiple segments, and each segment of that application becomes a container in itself or an application within the container in itself. And then multiple components of your application are talking to each other via the API. So rather than this structure where you kind of have, let's say if you have a 3-tier application and you're putting that all in a single container, versus you're front-ending that service or the individual components via an API, so that your web front-end is talking to your database through an API and not directly to the database itself or the container within that database. Now, why is this good? This architecture really helps a couple of ways. So for example, let's say this is my application. I have 3 different services, and each 3 service is backed by a container in itself. I want to change my front end, or I want to change my application or my mid-tier or my SQL service, right? I want to do some changes to it. Rather than updating each and every component of my application, I'm going to only focus on the delta or the part of app that I need changed, apply that change, and then move on. That's fundamentally the architectural advantage you gain by breaking down your application into multiple services. So let's say, for example, in this application, I have my front end at version 1.0, Everything else is at version 1.0. Now, my developers or dev teams created a new version that I want to apply. What I'm going to do is, first of all, I'm going to deploy the containers that have that application without changing my API service. My API service only talks to the containers that have version 1.10. And when I'm ready to switch, all I need to do is change this tag. The API points to the new containers. And that way, upgrading my containers or upgrading my application is super simple to do. That's one of the big advantages of going through a microservices architecture. You don't really need to manage update, OS updates, etc., etc. So containers do bring that capability, but with microsegmentation, you kind of enhance that capability further by doing this service-based architecture. Now, microservices are great, but they have its own challenges. When we are distributing an application into multiple components, there are multiple API services, forming your big application. Discovery of services becomes critical. Like, I don't know, before I had one big gigantic application, I know what it was in it. But now that I have broken it down, there are multiple services backing that application. I need to know what's going on, how many services do I have at any given point in time. A typical, if you're dipping them on the size of a company, you could have at least 10, 15 different services to 200, 300 different services, right? So how do you know what services are going on, which service is talking to what API, you want to at least have an understanding of what that distributed architecture looks like in case there is a problem. So distributed architecture is great, but then again, discovery becomes an issue with that. The other problem is, if all of these services are running in the same Kubernetes cluster, you want to manage access. Like, maybe you don't want your front end to talk to your database server, right? So you want to make sure that at the application layer or the API layer, you're having enough policies to manage all of that. Now, the other thing is, let's say you want to do some A/B testing, right? You want to manage traffic. Now, all of these are API servers. They are backed by load balancers. However, load balancers are not capable of being, they do not recognize traffic at a microscopic level. I can definitely split my traffic within a load balancer, but what if I want to maybe do some kind of an A/B test that based on geography? For example, if there's a specific traffic coming from this region, I want to point that traffic to a different version of my front end versus some other traffic coming in. Or if I have a certain set of users, I want to show them a different front end, maybe with a different language capability versus other traffic. So I want to split my traffic based on a specific condition. And how do I manage that within when I have multiple APIs pointing to a simple application or front end service? Now, that's where this is essentially managing all of these from a service API capabilities, managing a service mesh. And Istio is an open source project. It was created by IBM, Lyft, and Uber. And what Istio does is it has a control plane to manage your microservices. What it lets you do is, let's say you have multiple services, right? Service A, B, C. These are all the different API services that you have. It deploys a small proxy next to each and every service. And what that really helps is it's sending continuous data back to the control plane. This is the control plane of Istio. And it lets Istio understand what's going on, what services exist, how many services are talking to each other. You kind of get a discovery mode with Istio with the help of Envoy proxy next to your API gateway. Now, Istio itself also has multiple components, like the mixer component is essentially tracking your policy. It's tracking the telemetry data coming from these different proxies. It has Citadel, which is managing certificates. So if you have multiple services talking to each other and you want to manage TLS encryption, things like that, with the help of this component, you can easily do that. It also has a component called Pilot, which is essentially helping make sure that whatever policy is set is actually enabled. And then it has an ingress gateway. So Kubernetes, you can have multiple ways to exposing your application, a load balancer, a cluster-based, IP-based service, or you can even have an ingress gateway. So when you're deploying an application with Istio, you do need all the incoming or ingress traffic to go through this gateway so that Istio can then manage that traffic for you. So this is a very simplistic view of what Istio does. And so when it comes to VMware Cloud PKS, VMware Cloud PKS basically deploys Kubernetes cluster on a given cloud provider. For example, if you have AWS Cloud, it will provision a Kubernetes cluster for you on AWS Cloud. It's very similar to existing Kubernetes services like GKE or EKS that you have, except that it does so across clouds. Now, a typical Kubernetes cluster in VMware Cloud PKS looks like this. The cluster is created by a set of EC2 instances that are creating the master and worker nodes. And when you deploy your applications, all those applications are getting deployed in a pod within these different EC2 instances, or called the worker nodes or the master nodes. And then when we create a service API for each of these components, that is actually created using a load balancer, an elastic load balancer. So that's a very fundamental way of looking at a Kubernetes cluster created by VKE on AWS. VMware Cloud PKS on AWS. So what happens is when you deploy Istio on this, Istio will deploy a proxy service per pod. So if you have a front-end pod, an app pod, and a MySQL pod, Istio will start deploying proxy within each pod. And rather than having a load balancer that is directly routing your traffic to those pods, we deploy an Istio ingress gateway that is an elastic load balancer type. And then that gateway will have a virtual service that will manage what traffic comes in through that ingress gateway and which traffic gets routed to a specific service and then to a specific pod within that service. So this will be a different change in the architecture. The only change being that rather than having it exposed directly through the load balancer, when you're working with Istio or a service mesh, essentially, you want the traffic coming in through a service gateway. And the reason is you want to manage that traffic. So if it's coming through a single point, you know how to manage that. So that would be the difference when you deploy Istio within VMware Cloud PKS. Now, to get started, I want to make sure, go through some demo, right? So we are going to look at an application called Plane Spotter. It is a very simple application. This is the front end of the application. What Plane Spotter does is it has a registry where it looks up aircraft information. All the aircrafts that are registered within the FAA, it can look it up. So it has a simple registry to look up which aircraft belongs to who with their address, things like that. And this data is coming from the FAA directly. And then you also have aircraft details. So for example, if you have a specific aircraft like Boeing 373 or whatever, you can actually input that data and you can retrieve details about that aircraft. So it's a very simple application. The application has 3 tiers essentially. That one is the front end that we just saw. The other is the API server that is pulling data from a MySQL database. And then there's a Redis server, which is essentially refreshing the MySQL database with fresh data from the FAA database, right? If that makes sense. So MySQL server is where the local data is. The Redis server is essentially caching data from the FAA and pushing it into MySQL. The API server is getting details from MySQL and pushing it to the front end. It's a very simple application. So what I've done already is, with this demo, what I want to show you is I already have deployed that application. I'm going to inject Istio ingress gateway, Istio sidecar proxies into that application. And then we are going to take a look at how can we manage traffic based on that. So what I have is front end. What I did was, first of all, we need to deploy the Istio ingress gateway. I've already done that just to save time, but I'm going to go through the steps anyways. Then we are going to create a virtual service that will tell the gateway where to route the incoming traffic, and then we'll inject the sidecar proxies into this existing application. So to look at, I hope everybody can see the screen. All right, so this is my ingress gateway file. If you look at it, it is a very simple gateway where I'm describing that, I need a gateway named Plain Spotter. This is an ingress gateway by Istio, and it should be operating at port 80 or HTTP port. And then simultaneously, I'm creating a virtual service where I'm saying any traffic coming from host star, which means all incoming traffic, match it with the base URL of the Istio ingress gateway /index.html, registry.html details, and contact.html. Essentially, these are my front end endpoints that I want my incoming traffic to route to. And that traffic should go to the host Plain Spotter front end, because that's my front end API. I'm not exposing my API, the middle tier. I'm not exposing my database, nothing, just the front end. And hence, I need my gateway to just point to the front end layer. So I have this already created. Now I'm going to just go into, so this is the application that's already deployed. This is Plain Spotter. If you click on US aircraft data, it shows you all different databases. It has app health, and then it has contact information. So if you want to get in touch with the creator, you could do that. Now within my cloud, let's get to the CLI. So if I look at my, I need to authenticate, hold on. All right. So I'm just doing a kubectl get pods. Maybe I'll increase the font size a bit. That's better. So these are the application or the pods that are running within my namespace called Plain Spotter. So I have the front end Redis server, and if you notice, each of these different components have two containers running. One is the container that has the app, and one is the sidecar proxy running within the pod. That's why you see two instead of one. If you look at, for example, the AWS service, it only has one because I haven't created any sidecar proxy for that yet. And with that, I'm going to just go through the Istio gateway as well. So if I just do a kubectl get gateways, I already have a Plain Spotter gateway that I created using the YAML file that I showed. And essentially what's happening is the traffic is going from the internet to this gateway and then to your pods. Now if I get services, so I just did a services for my Istio system namespace. You'll see that the Istio ingress gateway has a publicly addressable URL called the Istio ingress gateway.vke demo1. Now, if I just go to this gateway, for example, if I just select that, and if I go to the gateway, I'm not going to get anything because I'm not matching a specific route that I've specified. Now, instead of this, if I just do /index.html, I get to my application. So essentially, what I'm trying to say is the API routes are now mapping. Now, what I want to do is I have the service running. I have Istio Sidecar created. What I want to do is, let's say I have an update coming up, and for this contact page, instead of the contact page, I want it to be a front end or a feedback page, right? And I want to do some minor changes. So I go back to my app dev teams. They created the front end changes needed to change this page to that. Now I want to push that changes, right? So here's what we are going to do. I already have a YAML file. I'm going to start deploying that with the Istio Sidecar proxy in it. Nope, sorry. So let me show you the YAML itself first. So this is another YAML that has my front end version 2. I already have version 1 that has the contact page. Now I need that contact page to go to version 2, which is a feedback page. And this is the deployment YAML for that feedback page, right? So I'm going to make sure that my application tier, everything matches with the original one because I want to test my app as the ingress traffic comes in. I wanted to ensure that it's routing to the correct addresses. And what I'm going to do is I'm just going to point it to this new image that I've created. It's called Boskey / plain spotter front end version 2. That's the container that I'm going to use. And let's start deploying this one. So I'm going to do a kubectl apply. So with that, I've created my plain spotter. Now if I just do list, if I do a list of my pods, you see version 2 coming up. Version 1 is still there, but version 2 is also coming up, and it has 2 container pods, which makes sure that the Istio Sidecar proxy is also installed. Now let's see what this means. If I go back to my front end, and if I refresh the page, I think it will take a couple of time to route the incoming traffic, but I should see a feedback page instead of the contacts page now. It's gonna take a little bit of refresh to make that happen. See, there you go. Now my front end has moved to feedback page. It was as simple as, now my Istio Ingress Gateway is still pointing traffic to both version 1 and version 2 because I have both those versions running. What it's going to do is 50% of the time it will route traffic to version 1 and 50% of the time it will route traffic to version 2. I can even control that. So I can create a policy that I can apply and say, you know what, instead of 50%, why don't you transfer 70% of the traffic to version 1 and 30% of traffic to version 2. So if I want to do some A/B testing, I could do that using a simple policy that I could create. So if I refresh this, it will go back to the contact page because it's mapping 50-50. So I think that was my demo, is to show the power of Istio with just microservices and Kubernetes. You can really extend your application, you can change it, and there are many things you could do. Right now we are just doing a very simple application. You can also make policies based on users. So let's say if this page had a user login, I could say for user 1, if that's the header that you see, route that traffic to version 3 or version 4 or something like that. It's very simple to implement all of that. The other thing I could do is rate limit. So for example, if I know I have multiple services going on and one of my services down and I want to apply an SLO to that service, I could define a policy based on that. So it's kind of circuit breaking the application itself, so that certain components of your application might not be running, but that doesn't mean that the complete app is down for that. So there are multiple ways you could manage and do things with a service mesh. All right? So that's all I had for this presentation. Thank you. Thank you. Thank you.